Okay, so this we're going to check if the number's prime, which means it is only itself and 1. If that's so, any other number that is divisible by automatically makes it impossible to make it divisible by 2.
Are you riding a motorcycle?
So this is going to be, if you look at here, this number here is a 0 at the end.
Yeah.
And the 0 at the end means that I could divide it by 2 because it's an even number. So at this moment, as soon as I see I could divide it by 2, this is not prime. Does anyone remember what the word for not prime numbers are?
Consecutive.
Close. It does start with a C, though.
Not consecutive. Why is it consecutive?
Composite. Good.
Why is it consecutive? Yeah. Wait, now it's on the recording. We seem so stupid.
And then 741. This one is not even, so we're going to have to check how to get this thing. So first,
The square root thing.
so I'm going to do the square root of 741.
Wait, so it's composite, that one?
The top one's definitely composite because it's even. I don't have to do the square root thing in a moment. Here, let's see. 741. What's the square root of 741?
Wait, the first one is composite.
Yeah.
How do you do the square root of 741 with calculator?
Pull up the calculator.
It's
Actually.
second, and then I think the x to the -1 button, and then
No, that would be matrix. So second to the x squared button.
Squared or something. I don't remember what it is.
So it should be from the 7 button up and left. So second square root. What was the number?
Square root 1.
741. So 27. So this is like 27-ish. So I want all the prime numbers up to 27. Now you should get used to your first prime numbers. 2, 3,
5,
good.
7, 11. Why?
These are prime numbers.
Is it 13?
13 is the next
Why are they
one.
prime? 13, 15, 15? No, that's 5.
17.
21?
19 is. 21 is absolutely not, though. Because 3 times 7.
Oh, yeah, 3. Yeah, 20.
23.
I'm confused. Why are these prime? 27 after that, or no?
27 is not prime.
25 is not.
So then you're good.
And that's it.
Okay.
Why are these prime?
What makes a number prime?
Because
Naomi?
one in itself. Oh, they only go into one?
Yes. Okay, so now what we do is we just divide 741 by each number to check if it's true.
That's a lot.
741 divided by 2, that's some decimal. That's not going to work. 741 divided by 3, you take your calculator. But this one I could actually quickly tell because it's 7, 4, and 1. If I add that up, 7 plus 4 plus 1, that's 11. 12. Since this is 12 over here, that's divisible by 3, right? 12 definitely, a 3 goes into 12, which means this is divisible by 3.
Yes? Because you did 7 plus 4 plus 1?
Yes, and that number is 12. The 12 is divisible by 3.
Wait, can we just add them together and then if that's the number? Like
If this is divisible by 12 or divisible by 3, then
so
it's
instead of
also.
dividing everything, we just do 7 plus 4 plus 1?
Yeah, you could do that to check for 3. That checks 3. So as soon as I figure out 3 is divisible by this thing, I can stop right there. And this is composite.
Wait, I'm saying, can I just do like, okay, so now I
Because
have,
3 times something gives you
after I
741.
write all of the prime, all the
Yeah.
the numbers,
As soon as I get one that hits, or
can
gives
I, I read all the prime numbers, then can I just do 7 plus 4 plus 1? And since that's 12, I look for whatever number goes into 12 evenly, and
no,
that's what it is.
stop, no. Because 7 plus 4 plus 1 equals 12, and then let's say 1 plus 2 equals 3, right? These 12 is divisible by 3, which means 741 is also divisible by 3.
Okay.
Okay?
Yeah.
So as soon as I figure out something's divisible by 3, I get my answer. So you could quickly tell at this point. Worst case scenario, you take your calculator, just divide each prime number, and then check.
But it'll come out as a whole number. Right?
Yes, 741 divided by 3 is some whole number.
Wait, but why is it? But when you put it in the 741, it gave you 27 point something. Wait, what makes it prime or composite?
7 plus 4 is 11.
No, when
plus,
you did the square root of 741 and you got 27, that was like a decimal.
Yeah, I know, but this square root just tells me how far I go to check. How many do I need to check?
What makes it prime? What makes it prime or composite?
Naomi, you answered this before. What makes a number prime?
No, but like for the answer, why is it composite?
Oh, because 3 fits into it. Let's do another one. 91. I'm going to do the square root of 91 to see how far I have to check. The square root of 91 is like 9 point something. So I'm going to go up to 9. So I got to put my prime numbers. 2, 3, 5, 7.
Is the answer 3?
No, the answer was composite. And you figured it out by 3.
5, 7, 11.
So we're doing 91 divided by 2. Is 91 even?
No.
No, so it's not divisible by 2. So I know that doesn't work. We'll do 91 divided by 3. If 91 divided by 3, 9 plus 1 is what? 10. Is 10 divisible by 3? No.
Oh, it's going to be 5.
So this is not.
It's going to be 5.
91 divided by 5.
Yeah, 'cause
In order
it
for...
goes into 5.
That's not how you do for 5.
No, but it doesn't matter because it's not 90 or 95.
Good. Because it doesn't end with a 0 or a 5, that means
Then it doesn't
5
work.
doesn't work. So you have to do 91 divided by 7. Sadly, there's no trick for 7. So you just divide it. And if you divide this, you'll get 13.
But either way, 91 over 5,
So
you still put it in.
this is still composite.
Why is it not 91 over 5?
You know it's not 91 over 5 because the ones digit here, right, is not a 0 or a 5. It has to be like 90 or 95 or 1065 or 70. All those numbers are over 5 because the ones digit is a 0 or 5.
And the reason why it's composite is because 13 is not one in itself. Or what?
Because 91, 7 times 13 gives you 91. That's why.
Yeah, because 13 times something, it's
Mhm.
not only one in itself.
Yeah. All right. Let's say you have 60. One question is going to be, give me the prime factorization. Do you remember what the prime factorization is?
That's the 6 and the 10, and
Tree.
then 2 and 5.
So I heard 6 and 10,
Oh, there's also 3 and 2, and then
3 and 2,
2 and 5.
2 and 5. So you make a tree, make sure every number goes down to a prime. But your answer, this is how your answer is going to look like. It's going to have a little slot on the quiz. 2 times 2 times 3 times 5. Okay? 2 times 2 times 3 times 5.
Mhm.
All right.
And then you just put it in to answer it.
If you want to check your work, you just do 2 times 2 times 3 times 5 in your calculator. It should go back to 60. If not, you made a mistake. We got something like 625. Here you just test a couple of things. I know for a fact this is divisible by 5. Naomi, why do I know for a fact this is divisible by 5?
Because there's a 5 in there?
Yeah. So I know it's going to be 5 divided by something.
You are surprised.
So it's 125. I'm happy.
So you just do 625 divided by 5, and you get that.
Then you'll get 125.
Wait, so how do you get 125? How do you
If as soon as you figure out it's 5, right? Like a 5 goes into it, you could do 625 divided by 5.
Okay.
And that will get you the other number, 125. Let's keep going. 125 is also divisible by 5. So 5 and 25. And 25 is also divisible by 5. 5 and 5. So this is 5 times 5 times 5 times 5. If you wanted shorthand, 5 to the 4th power. Also, up here, you could do a shorthand. 2 to the 2nd power times 3 times 5. Not necessary for me, but that's a shorthander version, okay?
Isn't there also like a 25 or no?
What?
5 times 5. There's
25 breaks down to 5 and 5.
Oh, I didn't do that.
All right. So prime factorization is important because the next section was greatest common divisor and least common multiple. So let's get the greatest common factor. So this is GCF of 111 and 267.
Is it GCF?
Yep, GCF.
Okay, so so what's 16 and 625 for? It's not GCF? What is that called?
This would be just ask you for prime factorization.
Okay.
So you just give me this. But in GCF and LCM, they're both going to make prime factorizations anyway. So like you're going to need that skill for the next section anyway. All right. So the prime factorization. So we're going to do 111 and 267.
Oh, I remember this from yesterday.
So this one, we're going to break it down.
3 and 37. I think it's 37.
Yeah. Now,
Yeah, 3 and 37.
for this one, you just got to check things that might multiply to 111. So you got to check. So in this case, you can see that it's 1 plus 1 plus 1. So I know for a fact this is divisible by 3. So 3, then you take a calculator, 111 divided by 3, 27.
And then.
Oh, wait, not 27, was it?
No, 37.
37. And this one over here, wait a second, if I do 2 plus 6 plus 7
So this
3
is
and
like
89.
prime factorization.
is 15. Yes, this is prime factorization, and then we'll do something at the end. Basically, there's an extra step. So this is definitely divisible by 3
And 89.
and 89. You quickly check 89 also, which you could do the square root thing. Notice how all the skills feed into each other. You could do the square root thing for 89, but hopefully you eventually
And if
figure
it's
out.
not a whole number, then there's.
If there's no whole numbers, then it's prime. You'll figure out eventually that 89 is prime and 37 is prime. So both of these are the primes. So the prime factorization for each one is 3 times 37 and 3 times 89. So,
Tell you that
I
it's
thought you have to multiply.
well, if I want the greatest common factor between this, those are the ones in common. So what's in common between both of these?
So 3.
The 3. So 3 and 3. So the greatest common factor here
You
is
always
3.
use that number.
And then don't you do.
They're just good
don't you
numbers.
do 89 times 111 and 37 times 2.
So if I'm looking for the least common multiple, I multiply what's different from each other. So 37 times this or 89 times this.
But you don't have to do both.
If you do both, you should get the same number. So that can check your work, but you only need one, really. So 89 times 111, 800. No.
1.
Ugh.
No. 9879.
Thank you. 9879. Okay. All right. Again, let's do another one. Let's
The
do
LCM is what?
9879. So you multiply what's different.
Can you give us a number that you never gave?
Yeah. I'm just looking in the book to give me some numbers that are plain, hopefully. Yeah. Let's do 63 and 105.
Is this also GCF?
We're going to do both. So we're going to do GCF and LCM. On a test, I'll make you do both in the same one, just because instead of you making do a fresh prime factorization, instead of making you guys do a fresh prime factorization each time, you could just combine them, right?
So it's like 6 plus 3 is 9.
Good. So that means it's what?
So it goes into 9.
Good. It actually does go into 9, and it also goes into 3. So let's do 9 and what?
Wait, can you also do.
Oh, 8,
Wait.
right? Or
7. Does 9 break down
Wait, you can
anymore?
also do 3 and 21. Though.
3.
You could have done 3 and 21.
That's what I did.
Good, but you got to break down 21. You're still going to get your prime factorization to
I'll
be
do the one you gave me.
3 times 3 times 7. Very important, though. No matter which way you do it, you'll get the same prime factorization.
And then for 105, we do 1 plus 5.
5 and
Which is 5.
21.
Oh, it goes into 5.
Well,
Since it
1 plus
ends
5
with
is 6.
5, then you just
Oh, 6.
So you could do 3, you could do 6, you could do 5.
5 and 21.
So 5 and 21 you could have done. 3 and 7. So 3, 5, 7. No matter which way you do it, you could have done 5 and 21, you could have done 3 and
GCF is
45 or 35. So GCF is?
3.
No. There's a 3. What else do they have in common?
Oh, it's missing a
Oh,
9.
7.
Oh, no, it's not. No, not missing.
Could it be
There's
3 and 7?
So 3 times 7.
21.
So the answer for that one is 21.
Wait, can you say that again?
Sure. Since I have multiple things that are in common, I have to multiply the two numbers. So in this case, I have 3 and 7 in common. So 3 times 7 is 21. And over here, I have to get the least common multiple, so I multiply by the one that's uncommon. Remember, choose whichever one you want. For me, I'm going to do 3 times 105. That seems easier. 315. Okay. Last thing we do is use these least common multiples of greatest common factors in fractions. So let's do that. So I'll purposely use this numbers to do the fraction, okay? Actually, we'll keep it over here. So one thing I could ask you to do is simplify a fraction. So technically, this would be a separate question. I'm going to use the same number, so I don't have to do a new factor tree, though.
We can add on. We'll add on to it, or
This would be, technically on the page, it would be different numbers. I'm just going to use the same numbers because we already did the tough part, which is the prime factorization. Okay, so let's say I give you 63 over 105, and I ask you to simplify.
Wait, how did you get the LCM is 5 and 3?
Mm-hmm. Say it one more time.
It's the ones that are left that don't match.
Yeah.
So how do you get 315 for the LCM?
You do 3 times 105 and 5 times 63. They'll both have the same answer. That's how you know you got the right one.
All right. For simplifying a fraction, when you do the prime factorization, you're going to divide what's in common. What's the most thing in common? We already figured it out. 21. Now, here's something I don't think I mentioned the first time. Since you multiply you took out what's in common, what's going to be left over is what's not in common. So if you notice over here, I had a 3 that was not in common on the left, and a 5 that was not in common on the right. So I actually already know my answer. I don't actually have to do 63 divided by 21. I know what should be left over, a 3. And I don't really have to do 105 divided by 21.
You know, there's a 5 left.
There's a 5 left. So actually, when you reduce it, you reduce everything that's in common, which means the leftovers are what's not in
You
common.
have to do that.
I mean, the question will be simplify a fraction, so yeah.
So
Okay, let's say it was a separate question and all you wrote on the paper was 63 over 105.
Okay.
And we didn't have the tree and everything.
So if we have
Then
63 over 105,
Now how would we do it? We don't
how I would do it is I would make the tree. I actually would make the tree.
So you would make the tree.
Yep. And then you eventually, after you make the tree
And you
21.
see the 2 numbers that are uncommon.
Hmm?
You see the 2 numbers that are uncommon and that's the fraction.
Yeah.
Okay.
why don't you just simplify it?
You
Well,
could. I'm giving you like an easy number here that you
How
could
would you
possibly
ask-
simplify. If I give you a more complicated one, you need a tree.
How would you ask the question? Find the,
Simplify this fraction.
That's it?
For that question, yeah. Another question would be add or subtract a fraction. So I'm taking one for the book. Let's do 5 over
Is this a new thing?
15. Not new, but it's a next section if that's what you're asking.
Is this
and-
on the quiz?
Yes. Everything I'm doing is on the quiz. And 6 over 7.
If you get the bottom, it's the same.
Good. I have to get the bottoms the same. The best way to do that is I'm going to factor the 15 and the 6. You could do a tree. If you get good at this, you could just list them. What multiplies to 15? 3 and 5, right? Those are the prime factors. And then 6 is 2 and 3. So once you get better at it, you need that. All right. They already have a 3 in common, so I don't need to include that, which means this 6 needs a 5, and this 15 needs a 2. That would result into 30, right? Because 15 times 2 is 30, 6 times 5 is 30. So I need to make it into 30. So here, I'm going to use a 2 over 2 because I'm trying to make 15 into 30. And over here, I'm going to use a 5 over 5 because I'm trying to make a 6 into a 30. So I'm going to have 2 times 5, which is 10 over 30, plus 7 times 5, 35 over 30. When you add fractions, you only add the tops. So you have 45 over 30. I'm also going to ask you, simplify if possible. Can we simplify this?
5.
You could take out a 5, but we could take out even more than 5.
I don't know why we both did that.
We could take out a Fit-
9? No.
not a 9.
No, that's only 45.
Well, how can we guarantee what we could take out? We could technically do a factor tree.
Or so much more than 5 and keep simplifying it.
You could do it like that too.
Oh, I hate these trees. There's so much work.
So in common, they already have a 3 and a 5.
The other one's just missing a 2.
So this one's missing a 2 and this one's missing a 3. So that means
3 over 2 over 3.
3 over
3
2.
over 2. Wait, how do you know which one to put first? 3 over 2 or 2?
The 45 has the 3 left over, so where 45 is on the top, 3 will be on top. And the 2 is what's left over on the 30.
So that would go over to the 45. Saying that it's like the 45 is missing the 2.
We're reducing, right? So we're taking out the 15 or the 5 and 3. So that means what's left over if we take out a 5 and a 3, there's only a 3 left over. So the 3 on top and the 2 on bottom. Okay.
Wait, after the the bottom's at the same.
Yeah. All right. Any questions? That's really, yeah, that's really good. We only had like 2 lessons.